Alright, this video is on Sohcahtoa, which is trigonometry. The ratio of the lengths of two sides of a right triangle is called a trigonomic ratio. The three most common ratios are sine, cosine, and tangent, which are abbreviated sine, cosine, and tan, respectively. Alright, so sine of R, angle R, this is angle R right here. Sine is opposite over hypotenuse. Opposite over hypotenuse. That's where we get Sohcahtoa from. This stands for sine is opposite over hypotenuse. Okay? All right, so let's look at that in the triangle. So opposite angle R. So opposite angle R is side lowercase r. And your hypotenuse is always across from the right angle. The hypotenuse is always across from the right angle, which is lowercase t. So it's r divided by t. All right, let's look at cosine. Cosine is adjacent over hypotenuse. Remember, you can pause this video at any time to take notes, to write, if you need more time to write. So up here, the C is cosine, and the A is adjacent, and the H is hypotenuse. So Sohcahtoa, C is cosine, A is adjacent, H is hypotenuse. All right, let's look at the triangle again. So this is cosine of angle R. Here's angle R. Adjacent is what is right next to it. So adjacent is what's right next to it. So that's side S. And the hypotenuse is always across from the right angle, which is T. All right, and tangent is opposite over adjacent. Opposite over adjacent, so tangent. Opposite over adjacent, that's what the TOA means. All right, so if we go back to angle R, we said that opposite was lowercase r, and adjacent is what's right next to it, which is lowercase s. Okay, now let's do it with some numbers. Find sine of A, cosine of A, and tangent of A. Express each ratio as a fraction and as a decimal to the nearest hundredth. All right, so sine of angle A. So you first need to find angle A. Remember, sine is opposite over hypotenuse. So this is opposite, which is 5. And the hypotenuse is across from the right angle, which is 13. So it said to express it as a fraction, so 5 over 13 is your fraction. And then it said decimal to the nearest hundredth. So we'll type this in our calculator. 5 divided by 13. And the nearest hundredth means 2 decimal places, so that's 0.38. All right, cosine of A. Cosine is adjacent over hypotenuse, and we're looking at angle A. So here's angle A. So adjacent would be the 12 over the hypotenuse, which is 13. And let's put that in our calculator to get the decimal. 12 divided by 13. So the hundredth place, go 2 places, 0.92. All right, and then tangent is opposite over adjacent. So opposite is 5, and adjacent is 12. So 5 over 12 is the fraction, and then the decimal, 5 over 12, is 0.42, the 6. If you have a number bigger than 5, it rounds that one up, so that's going to be 0.42. All right, in a right triangle FED, if tangent of D is 15 over 8, what ratio equals cosine D? All right, so here's our right triangle, so there's our right angle. Tangent of angle D, here's angle D, is 15 over 8. Well, remember that tangent is opposite over adjacent. So 15 is your opposite, and adjacent is 8. So that means opposite is 15, and adjacent is 8. What ratio equals cosine d? Well, cosine is adjacent over hypotenuse. So we know the adjacent is 8, but we don't know the hypotenuse. So in a right triangle, how can you find the diagonal? How can you find the hypotenuse? You can do the Pythagorean theorem. So a squared plus b squared equals c squared. Your diagonal is always your c. It's your hypotenuse. So c and hypotenuse are the same thing. So for a, it doesn't matter which one you put in. 15 squared plus 8 squared equals c squared. Type all that in your calculator. 15 squared plus 8 squared, 289 equals c squared. And don't forget this last step. A lot of you forgot it on the last test. You're trying to figure out c, so you need to square root both sides. So square root of 289 is 17. So c equals 17. So my hypotenuse is 17. So cosine, back to that, let's answer the question. Cosine is adjacent over hypotenuse. We said adjacent was 8, and now we know the hypotenuse is 17. So that's your answer. All right, so here's some more examples to practice with. Number 1, find sine j, cosine j, tangent j, sine L, cosine L, and tangent L. Express each ratio as a fraction. All right, this is a really good problem because it shows you it depends on what angle you're looking at. So sine of j, you need to find capital J. Sine is opposite over hypotenuse. So opposite of j is 12. Hypotenuse is always across from the right angle, which is 20. And that one can be reduced. 12 over 20, math, enter, 3 over 5. 4 goes into 12 3 times, 4 goes into 20 5 times. All right, cosine of j. Cosine is adjacent over hypotenuse, and so we're looking at capital J. Adjacent to it is going to be 16. It can't be 20 because 20 is your hypotenuse. And then if you want to reduce that, you can use your calculator, math, enter. You can also think 4 goes into 16 4 times, 4 goes into 20 5 times. All right, and tangent J. Tangent is opposite over adjacent. And so if I go to capital J, opposite is 12, and adjacent is 16. 4 goes into 12 3, 4 goes into 16 4, and again, you can use your calculator. Okay, now, make sure you pay attention to what I'm about to do next. We also have to do sine of L. Okay? Well, now we're looking at this letter. That's our starting point now. L is our starting point. So sine is opposite over hypotenuse. But now, if you start at L, the opposite is 16. The hypotenuse always stays the same. It's whatever's across from the right angle. So 16 over 20. And if you look back up, we know that reduces to 4 over 5. All right, cosine of L, adjacent over hypotenuse. Remember, you can always rewind the video. Just go back a few seconds or a few minutes if you need to hear something again. Cosine is adjacent, which is, so if you start at L, the adjacent would be 12, and the hypotenuse is still 20, and that reduces to 3 over 5. And then lastly, tangent of L is opposite over adjacent, so 16 over 12, which is going to be 4 over 3. All right, number 2 is a great problem for you to pause the video and try on your own. So pause the video, try it on your own, and then let's check your answers. So go ahead and pause it. All right, here are your answers. Sine of J, you might have 24 over 40, but that does reduce to 3 over 5. Cosine of J, you might have 32 over 40, but that does reduce to 4 over 5, and on the exam they will have the reduced fraction. Tangent of J, 24 over 32, 3/4. Okay. All right, sine of L, 32 over 40, but that does reduce to 4/5. Cosine of L, 24 over 40, that reduces to 3/5. And tangent of L equals 32 over 24, which reduces to 4 over 3. Okay, so for these first three, it was angle J, so that was your opposite. This was the hypotenuse, and this was the adjacent. And then whenever you're doing angle L, it switches. That's the opposite, and this would have been the adjacent. Okay? All right. Number 3, same concept, but now you have some square roots in there, so let's talk about that for a minute. So we'll start with sine of J. So here's angle J, so sine is opposite, so 36 over your hypotenuse, 24 over root 3. Okay, so you can reduce this part. Remember, we're not going to mess with the square root. So 36 divided by 24. Math, enter, enter. This gives you 3 over 2. And the square root's on the bottom. In math, you're technically not allowed to have square roots on the bottom. That's not going to be something we're going to really harp on or spend a lot of time on. But technically, in mathematics, you're supposed to multiply top and bottom by root 3. And so you get 3 root 3. And then you get 2 square root of 9, because 3 times 3 is 9. Well, the square root of 9, that's perfect. Square root of 9 is 3. So that gives you 3 root 3. And then this is 2 times 3, which is 6. And then that reduces again, so you get root 3 over 2. That's the technically correct term in mathematics, the correct answer. But again, in this class, we are more going to be practicing opposite over hypotenuse. Okay? All right, and let's look at cosine J. So here's J. Cosine is adjacent, which is 12 root 3 over hypotenuse, 24 root 3. I do want to show you on this one that the square root 3's cancel, and 12 over 24 reduces to 1 over 2. Okay? All right, and then tangent J. Tangent is opposite over adjacent. And for our purposes, you can leave your answer 3 over root 3. If you do 36 divided by 12 in your calculator, you get 3. Okay, part 2, finding side measures. You have to make sure your calculator is in degree mode. So go ahead and do that right now. Get your calculator out. Pause the video if you don't have your calculator out yet, but you should. Get your calculator out and go to mode. It's right here, one of the top buttons right there. Hit mode and go down and then go over to degree and press enter. So make sure it's bolded just like mine is. So you would go down over to degree and press enter. All right, so it's got to be in degree mode for these. All right, use the calculator to find the length of the missing side, round to the 10th decimal place. Set up a trigonometric function and use a proportion to solve for the missing side length. All right, so here's what we do. We start with our angle, and we need to label the sides that we have, or the sides that are marked. So opposite, and this one would be adjacent. Remember, hypotenuse is across from the right angle, okay? So we want to find out the opposite, and we have the adjacent. Well, O and A, which one is O and A? O and A is tangent. So I write tangent, and your angle always comes next. Your angle comes next. So tangent 64 equals opposite over adjacent. So opposite was x, and adjacent is 11, okay? All right, we want to solve that for x. Solve it for x. So we multiply both sides by 11. So those cancel. So the answer is x equals, so I'm going to do 11 times. The tangent button is right here on your calculator. Tangent of 64. You need to practice typing this in your calculator, guys. Make sure you can find the buttons. And so it said round to the nearest tenth, so that's going to be 22.6. Okay. All right, hint when solving, if x is on top, so right here x was on top, then you had to multiply both sides. If x is on the bottom, then you do the butterfly. Okay. All right, flip it over. All right, so let's do this problem. So you start with your angle and you label your side. So this is opposite, and then the one I'm trying to find is my hypotenuse, is across from the right angle. So Sohcahtoa. So O and H is sine. So sine. You always write the angle next. 63 equals. Opposite is 12. And hypotenuse is x. All right, so this is one where I'm going to need to do the butterfly because x is on the bottom. So put 1 on the bottom. So sine 63 times x equals 1 times 12 is 12. You're trying to get x by itself, so the opposite of multiplying is to divide. So you're going to divide by sine 63. Those cancel. X equals, remember you can pause this if you need to, 12 divided by sine 63, and you get 13.5. The 4 rounds up, so 13.5. Okay. All right, let's do this one next. So you start with your angle. This is adjacent, it's right next to it, and this one is hypotenuse, across from the right angle. So A and H is cosine. So cosine of 41, remember you write your angle right there, equals A, which is x over 32. Trying to get x by itself, so you multiply, do the opposite of dividing, multiply by 32. All right, and you type that in your calculator. 32 times cosine 41. And I get x is 24.2. X is 24.2. All right, pause the video. Try these next two on your own. So go ahead and pause it and then hit play when you're done and see if you have the correct answer. All right, so this is adjacent and this is hypotenuse, so that should have been cosine. You write your degree, your angle next, cosine 29, A over 29, multiply both sides by 29, and you should have gotten 25.4. And then for this one, this is opposite, and this is hypotenuse, so that would have been sine of 15. Equals x over 12, multiply both sides by 12, x is 3.1. All right, and part 3, finding angle measures. Use a calculator to find the measure of angle T to the nearest tenth. Must be in degree mode for these as well. The measures given are those of the leg opposite angle T and the hypotenuse, so write an equation using the sine ratio. Okay, so let's talk about that for a minute. So it said find angle T. It said find angle T. So let's put a x right there. Let's put an x in there. And let's label the two sides we have. We have opposite, and we have the hypotenuse. So O and H is sine. That's why they said to use that one. So sine, your angle always comes next. The angle goes there. Well, how many degrees is this angle? We don't know, so we put an X. Opposite, 29 over hypotenuse, which is 34. All right, this is brand new. You've never seen this before. We're trying to get X by itself. What is with the X right now? Sine. Sine is with the X. To get rid of sine, you do inverse sine. Here's what I mean. To get rid of sine, you have to do sine to the -1. That's the only way to get rid of it. So you do that to both sides. So you do sine to the -1 to this side, and sine to the -1 to this side. You do it to both sides. Sine to the -1 and sine cancel each other out. So I'm left with X equals inverse sine of 29 over 34. And you put this in your calculator. So let me show you how to do that real quick. So inverse sine, it's right here above the sign. It's in blue on my calculator. So you hit second sine. On everybody's calculator, this should work. Second sine, and then you get that -1. And then you type in the fraction, 29 over 34. And it said round to the nearest tenth. So that's going to be 58.5. And remember, this was an angle, so it's actually degrees. Okay. All right, let's do a few more examples. So it's still saying find angle T, so let's put our X in there. So we have opposite, and we have adjacent, so that is tangent. Tangent, your angle always comes next. Well, I don't know the angle, so I put my X. O over A, so O is 14√3 over 34. You're trying to get X by itself. To get rid of tangent, you have to do inverse tangent. Tangent to the -1, 14√3 over 34. All right, so let's type that in our calculator. So I'm going to hit second tan, 14 square root 3. And guys, on my calculator, I have to hit the over button. On your calculators, you're going to have to close the parentheses to tell the calculator to stop doing the square root. Divided by 34, and you get 35.5 on that one. The 9 makes the 4 round up to a 5. So X is 35.5 degrees. All right, you can always go back and replay that if you need to hear it again. All right, for all of these, we're finding angle T, so we'll put our X at the T. We have opposite, and we have hypotenuse. Hypotenuse is across from the right angle. So O and H is sine. Your angle comes next. I don't know what it is, put an X. And 7 over 18. Trying to get X by itself, so to get rid of sine, you do inverse sine. 7 over 18, so I'll put that in my calculator. Second sine, 7 over 18, and it gives you 22.9. And that is an angle, so it is in degrees. Okay. All right, number 3, put our X at the T. So we have hypotenuse, across from the right angle, and we have adjacent. So that would be cosine. Cosine of X equals, it would be A over H, so that is 34 over 87. Trying to get X by itself to get rid of cosine, I do inverse cosine, 34 over 87. And you get 66.99, so that rounds this whole thing up to 67 degrees. Okay. All right, pause the video, try this one, number 4, on your own. So go ahead and pause it and press play when you're done. or if you need help. So put an x here. So this is adjacent and hypotenuse, so cosine of x equals 32 over 101. The order in which you put your fraction does matter. And so to get rid of cosine, you do inverse cosine. So you type that in your calculator, you should get 71.5 degrees. All right, number 5, put my x here. So this is hypotenuse and adjacent. So that is cosine again. Cosine of x equals 10 root 3 over 67. To get x past 5, you have to get rid of cosine, so you do inverse cosine. And remember, when you type this in your calculator, second cosine, 10 square root 3, you need to close your parentheses if you have a TI-83, divided by 67. And so you get 75 degrees for that one. Okay. All right, number 6, if you want to try it on your own, you can. So you can pause it. So this would be, here's your x, so this is opposite and hypotenuse, so sine x equals 14 root 2 over 39, and do your inverse, and you get x to be 21.3 degrees. All right, for which value, last one, for which value of theta, that's how you pronounce that, for which value of theta is the statement sine of 40 equal to cosine theta true? All right, so for each of these, we're going to plug them in right there and see if we get a true statement. So sine of 40 gives you that. So now let's do cosine, and we'll start with answer choice A, which is 40. So we'll do cosine 40. Do you get the same thing? No. So now let's try cosine of 50. Cosine of 50. Does that match sine of 40? Yes, those are equal, so your answer is B. All right, remember you can always go back and replay any of the examples you want to hear again.